So in the last episode, you learned about some important properties of inverse trigonometric functions, and now in this episode, we shall solve some questions based upon those properties. And our first question is, find the value of sine inverse 2 upon 13. And the second part is sine of cos inverse 3 upon 5. So first, let's solve the first part. Sine of sine inverse 2 upon 13. And now as per properties of inverse function, you know it very well that sine of sine inverse x is equal to x for all x which lie in the interval -1 to 1. And now here x, which is 2 upon 13, lies between -1 and 1. So that means sine of sine inverse 2 upon 13 is equal to 2 upon 13. And now let's solve the second part, which is sine of cos inverse 3 upon 5. As per the properties of sine inverse functions, the sine of sine inverse x is equal to x. But here in the question, we have sine of cos inverse 3 upon 5. So first we shall have to change the angle representation of cos inverse 3 upon 5 into some angle representation of the type sine inverse x. And for that, let's draw a right angle triangle. Now cos inverse 3 upon 5 is the angle for a right angle triangle in which the ratio of base and hypotenuse is equal to 3 upon 5. Like in this triangle, you can say if base is 3 unit, then the hypotenuse is equal to 5 units. So in this triangle, we have got the values of two sides and the other side we don't have. Now let's find out the value of perpendicular. Now as per the Pythagoras theorem, the sum of perpendicular square and the base square is equal to the square of hypotenuse, which means 5 square is equal to perpendicular square plus 3 square. Or we can write perpendicular square is equal to 25 minus 9, which becomes 16. Or that means p square is equal to 16. And the p or the perpendicular is equal to under root 16, and which comes out to the value of 4. So that means the value of perpendicular in this case is equal to 4. And now with 4 as perpendicular and 5 as hypotenuse, so that means the sine of theta is equal to perpendicular upon hypotenuse, and which becomes 4 upon 5. And now as sine theta is equal to 4 upon 5, so that means theta is equal to sine inverse 4 upon 5. But this angle theta is the same, the cosine of which is equal to 3 upon 5. So that means the angle for which cosine is 3 upon 5 is the same for which the sine is equal to 4 upon 5. So in place of cos inverse 3 upon 5, we can also write sine inverse 4 upon 5. So the final equation becomes sine of sine inverse 4 upon 5. So that means sine of cos inverse 3 upon 5 becomes sine of sine inverse 4 upon 5. But you already know that as per the properties of inverse trigonometric function, the sine of sine inverse x is equal to x. So that means sine of sine inverse 4 upon 5 is equal to 4 upon 5. So therefore, sine of cos inverse 3 upon 5 is equal to 4 upon 5. So let's solve one more question. Find the value of, and the first part is cos of cos inverse 2 upon 13. And the second part is cos of sine inverse 3 upon 5. So let's solve the first part. Now here we have to find the value of cos inverse 2 upon 13. And remember, as per the properties of cos inverse function, the cosine of cos inverse x is equal to x for all x which lies in the interval -1 to 1. Now 2 upon 13 lies between -1 and 1. So that means cosine of cos inverse 2 upon 13 is equal to 2 upon 13. And now let's solve the second part, which is cos of sine inverse 3 upon 5. Now as per the property of cos inverse function, the cos of cos inverse x is equal to x. But here in place of cos inverse we have got sine inverse. So first of all we shall convert sine inverse into cos inverse form so that we can apply this property. Now sine inverse 3 upon 5 is the angle of the right angle triangle in which the ratio of perpendicular to the hypotenuse is equal to 3 upon 5. So let's draw a right angle triangle. And now here if the measure of perpendicular is equal to 3 units, then the value of hypotenuse is equal to 5 units. And here we don't have the value of the base or the adjacent side. Now as per the Pythagoras theorem, the square of hypotenuse is equal to the sum of squares of perpendicular and the base. So in this case, 5 square is equal to 3 square plus the square of base. Or we can write b square is equal to 25 minus 9, which is equal to 16. And that means b is equal to the square root of 16, which is equal to 4. So now base is equal to 4. and cos theta is equal to base upon hypotenuse. So here cos theta is equal to 4 upon 5 and theta is equal to the cos inverse 4 upon 5. And this is the same right angle triangle in which the sine is equal to 3 upon 5. So the angle theta is same both for sine inverse 3 upon 5 and for cos inverse 4 upon 5. So that means sine inverse 3 upon 5 is equal to cos inverse 4 upon 5. So in place of sine inverse 3 upon 5, we can write cos inverse 4 upon 5. So the expression cos of sine inverse 3 upon 5 now becomes cos of cos inverse 4 upon 5. And remember, from the properties of inverse trigonometric function, the cosine of cos inverse x is equal to x. So that means cos of cos inverse 4 upon 5 is equal to 4 upon 5. And that means cos of sine inverse 3 upon 5 is equal to 4 upon 5.